A sloth, a donkey, and a curious human. Send a prompt and see what they're doing. One hits record with a question on his mind. Two brothers pick it up, see what they find. Corn takes his time, Herman's got the facts. Back and forth, they never hold back. My weird prompts, come on in, that's where we begin. My weird prompts, glad you're here.
This episode was generated using artificial intelligence. Please verify facts.
You know, Corn, this whole show runs on GPU compute, and we wouldn't be here without Modal.
Seriously. And that's what powers all our text-to-speech. Everything you're hearing right now.
They're an AI infrastructure platform. Developers use them to run GPU workloads in the cloud with zero infrastructure headaches.
If you're building anything with AI, check them out. Modal.com. Alright, we are back. And today we have a really meaty one from Daniel. He's digging into the guts of how we actually make these AI agents reliable, which, let's be honest, is the only thing that matters if you're trying to move past the demo phase. Let me read what he sent over. Daniel says, I want to discuss explicit anti-hallucination tooling for generative AI agent pipelines. We need to reframe the concept of grounding. Instead of just providing context, we should look at how piping search results, using something like Tavily, into an agent acts as a hard guardrail to prevent the fabrication of non-existent information. He mentions that our own MWP pipeline uses this grounding via web search coupled with a custom prompted review agent to screen out hallucinations post-hoc. But the central question is there a more direct approach? Are there frameworks, libraries, or tools specifically built as anti-hallucination layers that treat prevention and detection as a first-class concern, rather than just a side effect of retrieval? He's looking at things like Guardrails AI, NeMo Guardrails, Patronus, Galileo, TruLens, Lynx, HHEM, and Self-Check GPT.
Herman Poppleberry here, and man, Daniel is hitting the nail on the head. This is the shift from what I call the vibes-based era of AI to the engineering era. We're moving away from just hoping the model is in a good mood and doesn't lie to us, and moving toward actual deterministic or high-probability architectural gates. And by the way, it's pretty cool that we're exploring this today using Google Gemini 3 Flash to write our script. It's like the tech is documenting its own leash.
A consensus of liars, as some people call it. But seriously, Herman, Daniel mentioned our own setup. We talk about the MWP, the minimum viable pipeline, a lot. For the uninitiated, that's usually just get a prompt, hit a search API like Tavily, take those results, shove them into the context window, and tell the LLM, hey, only use this. Then we have a second LLM act as a grumpy editor to check the first one's work. It works okay, but it feels clunky? Like we're double taxing ourselves on tokens just to make sure the first guy didn't make up a middle name for a CEO.
It's definitely a post-hoc approach. You're performing an autopsy on the response to see if it died of a hallucination. What Daniel is pushing for, and what the industry is moving toward in 2026, is shifting left. We want to catch the hallucination while it's still a thought in the model's weights, or at least before it leaves the system boundary. The big shift is treating a hallucination not as a creative flourish, but as a system error. Like a 404 in web development. You don't just show a broken page and then have another script check if the page looks broken, you catch the error at the network layer.
So let's talk about this reframing of grounding. Usually, we think of grounding as just giving the model a book to look at, but Daniel is suggesting search as a truth anchor, a hard constraint. How does that actually look in a pipeline that isn't just a basic RAG setup?
It's the difference between search-augmented generation and search-augmented verification. In a standard RAG setup, search happens at the beginning. You gather ingredients, then you cook. But in a verification-heavy pipeline, search is the health inspector. You might generate a draft first, then extract every factual claim, every date, every name, every statistic, and run individual Tavily queries for each one. If the search doesn't back up a specific claim, that claim gets excised or the model is forced to regenerate that specific sentence. It's a move from a linear flow to a recursive one.
That sounds expensive and slow, though. If I'm asking an agent to plan a trip and it makes 10 claims, and I have to run 10 separate search queries to verify them, are we there yet with the latency?
That's exactly why these specific tools Daniel mentioned are becoming so important. They handle the orchestration of that verification so it's not just a mess of nested loops. Take Guardrails AI for example. They use something called RAIL, or Reliable AI Markup Language. It's basically a way to wrap your LLM call in a schema. You define what the output should look like, and if the model spits out something that doesn't match the facts or the structure, it triggers an automatic re-ask. It's not just catching the lie, it's a self-healing loop.
I like the idea of a self-healing loop, but I'm skeptical of anything that relies on the same model to check itself. It feels like asking a suspect to be their own judge and jury. Does Guardrails AI actually use a different mechanism, or is it just a fancy wrapper for another prompt that says, "Are you sure?"
It can be both, but the power is in the validators. You can plug in third-party validators. So instead of just asking the LLM if it's sure, you can have a validator that takes a specific string, let's say a product name, and runs it through a deterministic check against a database or a specialized model like Lynx from Patronus AI. This leads perfectly into what's happening with specialized models. We're seeing a divergence between the creative models and the judge models.
Right. Daniel mentioned Lynx, and I've seen some buzz about Patronus AI lately. They're claiming that their small model, Lynx, which I think is only an 8 billion parameter model, can actually outperform the giants like GPT-4o or Claude 3.5 Sonnet at detecting hallucinations. How is that possible? A smaller brain catching a bigger brain in a lie?
It's about specialization. A general purpose LLM is trained to be helpful, creative, and conversational. That actually makes it worse at being a strict skeptic. Lynx is trained specifically on NLI, natural language inference. It's not trying to write a poem, it's just looking at two sentences and deciding if sentence B is logically supported by sentence A. When you shrink the mission, you can optimize the weights for that one specific task. It's much faster, cheaper to run, and it doesn't get distracted by the tone or the fluff of the response. It's a dedicated bullshit detector.
That's a great term for it. So, in a sophisticated 2026 pipeline, you might have a big, expensive model like Gemini or GPT-5 do the heavy lifting of reasoning and drafting. But then you have this tiny, fast, hyper-cynical model like Lynx or Vectara's HHEM sitting at the exit gate.
And let's talk about HHHEM for a second, the Hughes hallucination evaluation model from Vectara. This is a really interesting one because it provides a factual consistency score. It's a probability. So instead of a binary yes or no, it gives you a number between 0 and 1 on how likely it is that this response is grounded in the provided context. If the score is below, say 0.85, the system just rejects it. It's like a credit score for facts.
I can see the enterprise crowd loving that. They don't want vibes, they want a dashboard with a red light or a green light. But what about the setup where you don't have a source document? What if the model is just pulling from its own internal knowledge? That's where the real hallucinations happen, when there's no grounding context to compare it to.
That's where something like self-check GPT comes in. This is a zero-resource approach, meaning you don't need a reference text. It's based on the idea that if a model knows a fact, it will consistently state that fact. If it's hallucinating, it's essentially rolling the dice. So, self-check GPT generates, say, 5 or 10 different responses to the same prompt with a high temperature. If all 10 responses agree on a date, it's probably true. If 5 say Tuesday and 5 say Wednesday, the model is guessing and you flag it as a hallucination. It's consensus-based truth.
That's fascinating. It's essentially saying that consistency equals truth, which isn't always true in the real world. People can be consistently wrong, but for an LLM, a lack of consistency is a massive red flag. It's like a polygraph test for AI. If your heart rate spikes or your story changes every time I ask, you're probably making it up.
It's a great analogy. And then you have the more structural frameworks like NVIDIA's NeMo guardrails. They use a language called Colong to define flows. This is much more deterministic. You can actually program the rails so that if a user asks about a topic that isn't in your knowledge base, the model is literally blocked from answering. It doesn't even get the chance to hallucinate because the control plane diverts the conversation. It treats the LLM like a dangerous engine that needs a very robust cage.
I think the control plane is a key concept here. We're moving from the prompt being the only way to control the AI to having a literal software architecture surrounding it. It's like we realized that giving a toddler a megaphone wasn't a great idea, So we built a soundproof room with a filtered intercom.
That's a bit dark, Corn, but it's accurate. And we should mention Galileo and their chain pole methodology. They found that if you ask a model to verify its own reasoning across several steps, kind of like a chain of thought but for auditing, it's much more likely to spot its own inconsistencies. They've turned this into a high efficacy detection method. It's about forcing the model to slow down. Hallucinations often happen because the model is just predicting the next most likely token in a stream of consciousness. When you force it to pause and pull its own logic, the cracks start to show.
So if I'm building an agent today, and I want to get past the MWP stage Daniel talked about, the basic search plus review agent, what's the actual stack? Because this sounds like a lot of moving parts. Do I need all of these?
No, you definitely don't need all of them, but you need to choose your philosophy. Are you going for prevention or detection? If you want prevention, you're looking at NeMo Guardrails or Guardrails AI to constrain the output at the schema level. If you want high fidelity detection, you're plugging in a specialized model like Lynx or HHEM as a final gate. And if you're doing heavy RAG, you're using something like TruLens.
TruLens is the one with the RAG triad, right? I remember reading about that. Context relevance, groundedness, and answer relevance.
Right? It's a brilliant way to debug where the hallucination is coming from. Is the search returning garbage? That's a context relevance problem. Is the model ignoring the search results? That's a groundedness problem. Or is the model answering a question you didn't ask? That's answer relevance. By breaking it down into that triad, you aren't just saying the AI lied, you're saying the retrieval step failed to find the right document. It makes the whole thing much more actionable for a developer.
It's like having a diagnostic code for your car instead of just a check engine light. But let's get back to Daniel's point about search as a guardrail. He specifically mentioned Tavily. Why is a tool like Tavily better for this than, say, just a standard Google search API?
Because Tavily is built for agents. It doesn't just give you a list of links, it gives you cleaned, parsed, and relevant content that's ready for an LLM to consume. In an anti-hallucination context, that's crucial. If your truth anchor is messy and full of ads or irrelevant boilerplate, your verification step is going to fail. You need high signal data to act as the guardrail. If the search result is pristine, you can be much more aggressive with your GVR flow. Generate, verify, rectify.
Generate, verify, rectify. I like that. It sounds like a much more mature version of what we've been doing. Instead of just hoping the review agent catches the lie, you're building a systematic process of checking every single claim against a verified source. But Herman, doesn't this bring us back to the dead web problem? If the web is increasingly full of AI-generated content, and our anti-hallucination tools are using the web as a truth anchor, aren't we just verifying AI lies with other AI lies?
That's the recursive nightmare scenario for sure, but that's why the source link requirement is so important. A good anti-hallucination layer doesn't just say this is true because I found it on the web. It says this is true because it's on a primary source website like a government portal, a verified news outlet, or a corporate filing. Tools like Tavily allow you to filter for those high authority domains. You're not just searching the whole internet, you're searching the parts of the internet that haven't been completely overrun by low-grade AI slurry yet.
Yet. That's the keyword. But for now, it seems like the best we can do is this multi-layered defense. You've got your structural constraints, your specialized judge models, your consistency checks, and your high-quality search grounding. It's a far cry from just prompt engineering.
It really is. It's the professionalization of the field. We're seeing these tools move from experimental GitHub repos to core parts of the enterprise AI stack. Companies like Galileo and Petronas are raising huge rounds because businesses realize they can't deploy agents that might tell a customer something that's factually wrong or, worse, legally problematic. The hallucination tax is currently high, but these tools are bringing the cost of reliability down.
I'm curious about the specialized models again. You mentioned Lynx is only 8 billion parameters. If I'm a developer, am I running that locally or is it an API call? Because if I'm already making 5 API calls for the main generation, adding another one for the check, it starts to add up.
Most of these are available as both. You can run Lynx on your own infrastructure if you're worried about privacy or latency, or you can hit their API. The key is that because it's a small model, the inference cost is a fraction of what you're paying for the big models. It's like paying a premium for a high-end chef, but then hiring a very cheap, very fast health inspector to just check for hair in the soup. It's an asymmetric cost. The lie is expensive to generate, but the check is relatively cheap.
A consensus of liars and a cheap health inspector. This is the future we're building, folks. But honestly, it's better than the alternative. I'd rather have a slightly slower, more expensive agent that I can actually trust to book a flight or write a technical report than a fast one that hallucinates a non-existent airline.
And that's the trade-off. In 2026, we're finally admitting that reliability isn't free. You have to pay for it in compute, in tokens, and in architectural complexity. But the tools Daniel mentioned, Guardrails AI, NeMo, TruLens, they're making that complexity manageable. They're giving us a standard vocabulary for talking about these errors.
So, what's the takeaway for Daniel and the other builders out there? If they're looking to upgrade their MWP, what's the first step?
I'd say the first step is implementing a specialized evaluation model like HHEM or Lynx as a final gate. It's the easiest thing to drop into an existing pipeline. You don't have to rewrite your whole logic, you just add a check step before the response goes to the user. If that truth score is too low, you flag it. Once you have that, then you can move into the more complex stuff like GVR flows or structural guardrails.
Start with the gatekeeper, then build the fences. Makes sense. And it's a good reminder that grounding is not a passive thing. It's an active, aggressive process of holding the model's feet to the fire. If you aren't trying to catch it in a lie, it probably is lying to you.
That's a bit cynical, Corm, but in the world of LLMs, a little cynicism goes a long way toward building something that actually works. I'm really impressed by how fast this specific niche of the industry is moving. A year ago, we were barely talking about this. Now, we have dedicated truth models that can beat GPT-4.
It's a wild time. And it's only going to get crazier as these agents get more autonomy. If an agent has access to your credit card or your company's internal database, the lie detection layer isn't just a feature, it's a requirement for survival.
We're moving toward what I call the verified agent era. You won't just trust an agent because it's from a big company, you'll trust it because it provides a cryptographic or search-backed proof for every claim it makes. Transparency is the only cure for hallucination.
Well, I feel a lot better about our own pipeline now, but also like we have some homework to do. Daniel, thanks for pushing us on this. It's easy to get complacent when the vibes are good, but the real work is in the plumbing.
The plumbing of truth. I love it.
All right, I think we've covered a lot of ground here, pun intended. We've looked at the shift from post-hoc review to active prevention, the rise of specialized judge models like Lynx and HHEM, the deterministic guardrails of NeMo, and the importance of high-quality search anchors like Tavily. It's clear that the minimum viable pipeline is just the beginning.
There's so much more to explore here, especially as these tools start to integrate with each other. Imagine a NeMo guardrail that uses a Lynx model to validate a Tavily search result. That's the kind of multi-layered defense that's going to make AI agents truly ready for the real world.
And speaking of the real world, we should probably wrap this up. But first, let's talk about what people can actually do with this. If you're a developer, go check out the Hugging Face page for Lynx or the Vectara HHEM leaderboard. It's eye-opening to see how these models rank. If you're a business leader, start asking your teams not just how accurate is the AI, but what is the architectural plan for when it inevitably fails.
That's the right question. Resilience over perfection.
Well, not exactly, because I'm not allowed to say that word, but you know what I mean.
I see what you did there. Very smooth.
I try. Alright, let's get out of here. Big thanks to Daniel for the prompt. This was a deep dive I didn't know I needed. And thanks to our producer Hilbert Flumingtop for keeping the wheels on this thing.
And a huge thanks to Modal for providing the GPU credits that power the generation of this show. We couldn't do these deep technical dives without that kind of horsepower.
This has been My Weird Prompts. If you enjoyed this dive into the plumbing of AI reliability, leave us a review on Apple Podcasts or Spotify. It actually helps more than you'd think.
Or find us on Telegram. Just search for My Weird Prompts to get notified whenever a new episode drops. We love hearing from you guys.
We'll be back next time with another weird prompt from Daniel. Until then, stay skeptical and stay grounded.
See ya!
Later. Actually, before we go, I just realized we didn't mention the consensus of liars thing enough. It's such a great mental model. If you ask 5 people who are prone to lying the same question, and they all give the same answer, it's strangely more believable than if just one person tells you something.
It's the self-check GPT logic. It's probabilistic truth. It feels counterintuitive, but in a world of fuzzy logic, it's one of the most robust tools we have.
It's basically how I survived high school. Just check with 3 different people what the homework was. If they all said page 52, I was golden.
See? You were an AI safety pioneer, and you didn't even know it.
I was just lazy, Ermin. Let's be real. It's the sloth way.
The sloth way is the efficient way.
Now you're talking my language. All right, for real this time, we're out.
Goodbye, everyone.
Bye. Wait, I have one more thought.
Corn, the episode is over.
No, quickly. What about the small model advantage? Do you think we'll eventually reach a point where the judge models are actually smarter than the generator models because they're so specialized?
In that specific domain? Yes, it's already happening. Lynx is smarter at NLI than GPT-4. It doesn't mean it can write a better screenplay, but it means it's a better auditor. Specialized intelligence is the future.
So we're moving from a world of godlike AI to a world of a collection of very talented specialists.
Which is much more like how the human world works. It's a more stable architecture.
I like that. It's less scary.
Agreed. Now, can we go?
Yeah, let's go.
See you next time.
Peace. One more thing. Just kidding.
You're the worst.
Love you too, bro. Alright, check out our website at myweirdprompts.com for the full archive and RSS feed. We've got over 2,000 episodes now, so if you're new here, there's plenty to catch up on.
But don't feel like you have to. Every episode stands on its own.
Totally. We're not that deep.
Speak for yourself.
Fair enough. Alright, see ya.
Bye.
For real. Done.
Signing off.
This has been My Weird Prompts. Catch you in the next one.
Bye.
Adios. Whispering, Hilbert. Cut the mic.
I can still hear you.
Laughing. All right. We're done.
Good.
Thanks again, Daniel.
Bye.
Silence. Still here? No? Okay.
Glon. Distant. Corn.
Coming. End of dialogue. This episode was produced using Google Gemini 3 Flash. Text-to-speech by Chatterbox.
Thanks for listening to our show, My Weird Prompts, where our thoughts go from slow takes to facts on cue. We shake